Hello, I am Erdem from UVision. In this video we will solve a question about inductors and its properties. First, let's observe the circuit. We have three inductors and they are shorted within themselves independently, and their currents flow through the short branch and on their cells, and they have initial currents I1, I2 and I3. And let's look at the question. All switches are opened at t equals 0. So these switches are opened at t equals 0. What happens? They immediately become in series, right? Right now they are not in series, but after switch open, they become in series immediately. And it's asked to find common current I flowing through inductors. Now, do you remember something? I have told you that switch opening questions will be about mostly conservation of flux, and we will use conservation of flux principle to find common current I. Now, in the first situation, what is total flux in the circuit? Here we have I1 L1 amount of flux, right? And here I2 L2 amount of flux. Here I3 L3 amount of flux. We need to sum them up. Then I1 L1 plus I2 L2 plus I3 L3 is total flux. Alright? And what's the circuit in the second case? We have here L1, here L3, here L2 and L3 here. And there is a common current flowing through these inductors, right? Because they are in series. By KCL, only one current flows in the circuit, and these are in series, so we can reduce them into one single inductor with an inductance L1 plus L2 plus L3, right? And if you multiply this inductance with the common current, we can find the total flux in the circuit in the second case. So this is T1, let's call this total flux 1, and total flux 2 is simply IC times L1 plus L2 times L3, and let's call this T2. Since flux is a conserved property, T1 is equal to T2, and by equating them into each other, we can find IC as follows: I1 L1 plus I2 L2 plus I3 L3 divided by L1 plus L2 plus L3, and this is the result. Actually, this is the common current flows through the inductors after opening of switches. You could solve this question by applying initial condition model. You can replace the inductors with initial model, including a voltage source. Alright, it will be like this. Sources will supply, of course, inductance times initial currents and a delta source. And by using this delta, you will include it in the integral equation, and you could have solved this question in that fashion also. You can try it on your own and you will find the same result. That's all for this video. Thanks for watching.